When the heavens move, the earth trembles. And now it's happening again. For as long as humans have looked up, they have watched the night sky for signs. Ancient civilizations read the heavens like open pages. Comets were omens, meteors were messages, and the sudden, blood-red sweep of a celestial visitor could mean kings would fall or rivers would flood. The ancients painted these sky fires in clay and carved them into stone, their chronicles threaded with warnings. A star, with a tail across the sky, a season of sickness, a great shaking beneath the feet. For centuries, modern science has tried to separate the poetry from the physics, teaching that comets are icy relics, not portents, that stars explode and planets quake for reasons rooted in matter and motion, not fate. We comforted ourselves with equations, with statistics, with the steady tick of instruments. The sky, we told each other, is deaf to human hopes and fears. And then, on a late September night, the old stories and new measurements collided. It began in Venezuela. At 22:21 UTC, a violent rupture of the crust sent a tremor through the nation. Magnitude 6.2 on the seismograph, rocking cities, buckling roads, toppling brittle masonry. Hours later, while first responders were still searching for survivors and aftershocks were rattling the region, a second, deeper event struck. Magnitude 6.3. A different signature, but nearly identical in destructive energy. The instruments recorded it as two distinct releases of strain in the same tectonic block, separated by only hours. The world took notice because such clustered, high-magnitude quakes in that region are rare. People reached for explanations: fault stress, fluid migration, unlucky timing. Scientists began compiling data. At the same time, measured and logged on satellites and at observatories far above the planet, the sun misbehaved. A coronal mass ejection, a vast bubble of plasma and magnetic field hurled from the sun's surface, slammed into the heliosphere. The steady pressure of the solar wind fluctuated, and in a narrow interval, the measured density dropped unusually low, creating a transient relaxation in the stream of charged particles flowing past Earth. When the solar wind eases, our planet's magnetosphere breathes out. The bow shock that normally compresses the magnetic field relaxes, and the field lines that wrap Earth's globe slacken. That isn't just an abstract shift. It changes how the magnetosphere couples to the ionosphere and how currents flow through the near-Earth environment. Geophysicists have long debated whether such space weather events can nudge things geological. The consensus used to be that the crust ignores the heavens. Earthquakes are the language of plate tectonics and geology, not of solar storms. But a growing body of research suggests the coupling isn't negligible. Consider the magnetosphere as a shield pressed tight against a drumhead. When the external pressure eases, the drum's skin subtly relaxes, and stresses locked in the crust can redistribute. Sudden shifts in ionospheric currents can induce tiny electrical forces in conductive rocks, subtly changing friction at fault interfaces. Alone, none of these effects seems capable of triggering a magnitude 6 quake. Yet when they coincide, when solar pressure ebbs at the very hour when tectonic stresses are near a tipping point, the odds shift. A marginal fault can be prodded over the edge. It is in that precise, dangerous window that something else arrived. Astronomers had already catalogued the object months before. 3I-ATLAS, shorthand for the third, confirmed interstellar interloper spotted by survey telescopes. After Oumuamua in 2017 and Comet Borisov in 2019, 3I-ATLAS entered our records as another fleeting whisper from beyond, an icy or rocky fragment flung out of another star system, perhaps the product of planet formation or a violent gravitational interaction. Such visitors are usually unremarkable in the cosmic sense. They sweep through, reveal a hint of chemistry, and vanish. But 3I-ATLAS did not act like the others. As solstice turned toward equinox, and the sun's activity climbed, ground-based and space-based instruments began to catch odd behavior. Telescopes noted a coma, the fuzzy atmosphere that forms around a comet, far larger and more structured than its size should allow. Instead of the classical fantail that streams directly away from the sun under solar wind pressure, one portion of 3I-ATLAS's coma seemed to point sunward, as if tugged by an unseen tether. Parts of its plasma tail arced and braided with filamentary structures, threads of charged gas twisting in ways no simple sublimation model predicted. When a CME struck it weeks earlier, the object flared, brightening by an order of magnitude, nearly 20 times more luminous, and then dimmed, not in a smooth decay, but in abrupt, step-like pulses. Each pulse read like a response, not a passive burn. Imagine watching a floating lantern that suddenly flashes brighter when a gust of wind passes, and then seems to adjust as if aware of the breeze. That metaphor is imperfect, but it captures the unease. 3I-ATLAS seemed to react to the sun's fury in ways that suggested more than chemistry. The solar storm did not merely sculpt the object's tail, it provoked it. During the exact window of the Venezuelan ruptures, two other remarkable phenomena were recorded. Observatories in the southern hemisphere logged sudden stellar outbursts, novae, one in Centaurus and another in Sagittarius. Novae are not frequent, and two near-simultaneous detonations are exceptional. At high latitudes and lower than expected latitudes alike, auroras painted the sky green and crimson as geomagnetic indices spiked. Magnetometers from Canada to Japan registered irregular pulses, brief, synchronized anomalies not entirely consistent with normal geomagnetic storms. And in orbit, satellites monitoring Mars reported faint auroral glows and short-lived electromagnetic spikes in its tenuous atmosphere. Effects curious to see on a planet with only patchy magnetic remnants. Taken independently, each event could be dismissed. Earthquakes happen, the sun erupts, stars flare in distant neighborhoods, but coincidence stretched thin. The timing of the Venezuelan quakes, the sun's transient relaxation, the dual novas, and the sudden animated behavior of 3I-ATLAS overlapped in hours, not days. That temporal alignment lit a fuse in the scientific community. Researchers who spend their lives reducing uncertainty found themselves looking at a bucket of converging anomalies that statistics strained to smooth. History added a disquieting echo. Long before seismometers and spectrographs, human cultures chronicled the same kind of synchronous phenomena, comets and calamities described in the same breath. Babylonian tablets inked fiery stars above accounts of tremors. Chinese imperial records paired celestial broom stars with drought and unrest. For centuries, these records were footnotes for folklorists. Now, with satellites and networks of sensors, the old accounts gained a modern resonance that scholars could not easily dismiss. Skeptics counseled patience and caution. Correlation is not causation. The universe is large and noisy. Humans are trained pattern makers, prone to seeing orchestration in chaos. Many emphasized that comets alone cannot pry open Earth's tectonic scars. But the data continued to pile up in an uncomfortable chorus. Instrumentation that had been reliable for decades recorded unexpected couplings. Magnetospheric pressure fluctuations close in time to seismic release, auroral belts displaced far from their predicted latitudes. 3I-ATLAS, altering its output in direct reaction to incoming solar energy. As the object edged inward on its path, approaching a critical alignment with Mars, and soon thereafter conjoining with the line of Earth and Sun, researchers working the datasets began to whisper of resonance. Not mystical resonance, but physics. Systems can exchange energy across scales when their frequencies lock. A violin string vibrates sympathetically when another tuned to the same pitch plays. A glass shatters when sound matches its resonant frequency. If the Sun, a charged interstellar body, and Earth's magnetosphere and crust happen to share transiently compatible modes, then a tiny perturbation in one can amplify in another. What that could mean, practically, raised the hair on the backs of spines. A coma charged by plasma, responding non-linearly to CME impact, could act as a conduit or amplifier for solar energy. That amplified energy could reshape local magnetospheric currents. Those currents could shift ionospheric coupling. And that, in turn, could tweak the minuscule electromagnetic forces at fault interfaces, already strained by tectonic loading. It remained speculative, very speculative, but the math left a sliver of plausibility, where once there had been none. So the machines kept watching. Satellites focused on Mars logged the faint auroral displays. Seismographs around the world quietly scanned for new patterns. Astronomers trained larger telescopes on 3I-ATLAS, recording each flare and tail twist. Newsrooms buzzed with nervous headlines. Agencies exchanged terse cables. And through it all, 3I-ATLAS continued its slow, inexorable approach, a crimson whisper in the dark, reacting to solar pulses like a bell struck and left to ring. Something had begun to resonate, not just above us, but within the bones of the Earth. For weeks, the strange visitor drifted closer, its behavior defying every model astronomers used to predict how comets and asteroids should behave. 3I-ATLAS was supposed to be a silent wanderer, a relic of some alien solar system passing through ours without incident. Instead, it had become something else entirely, a resonant instrument in a cosmic orchestra that no one realized was playing. It began with the tail, or rather tails. Most comets display two, a dust tail that glows with reflected sunlight and a plasma tail driven away by the solar wind. But 3I-ATLAS broke that rule. One tail indeed streamed outward, a luminous band of charged ions curling away from the sun. Yet another, fainter one pointed toward it, a defiance of physics that unsettled even veteran comet scientists. In images from ground-based observatories, the twin tails twisted around each other in spiraling filaments, weaving like strands of DNA. Their motion wasn't random. The structure pulsed. Every few hours, the sunward tail contracted and brightened, while the anti-solar one expanded, almost as if the object were inhaling and exhaling the solar wind. Spectrographs measured the coma, the cloud of gas and plasma surrounding its nucleus, ballooning outward until it spanned 100,000 kilometers, larger than Jupiter. The expansion wasn't smooth. Instead, it rippled in sync with solar weather. When a coronal mass ejection blasted through space, the coma erupted in violent surges of light, its luminosity spiking 20-fold. Astronomers initially labeled it hyperactive sublimation, but as the pattern continued, that explanation faltered. 3I-ATLAS's energy output exceeded anything its small nucleus could sustain by ordinary means. It wasn't simply venting gas, it was responding. The object flared brightest when the solar wind intensified, as if feeding on it. Solar probes monitoring the heliosphere confirmed what visual telescopes were already hinting at. Each flare coincided with a measurable perturbation in plasma density across millions of kilometers of space. The sun's own magnetic field appeared to tremble. Then, on October 2nd, a new pattern emerged. Two distant stars, a red giant in Cygnus and a white dwarf in Lepus, suddenly brightened, each unleashing a nova within hours of one another. The odds of two unconnected stellar explosions occurring so close in time were astronomically low, yet they did, and the timestamp on the first nova matched, within minutes, a sharp flare in 3I-ATLAS's light curve. The coincidences multiplied. As the object continued its inward drift, geomagnetic storms intensified on Earth. Auroras crept down from the poles to paint skies as far south as Spain, Japan, and the Caribbean. places where green curtains of light hadn't danced in living memory. Satellites in orbit began recording sudden electrical discharges, small but unexplained. Magnetometers picked up rhythmic oscillations, faint pulses sweeping through the field like a heartbeat. Even stranger, seismographs around the globe registered a subtle uptick in micro-quakes, tiny tremors that rippled through the crust. None were catastrophic, but their global distribution and synchronized timing defied normal tectonic behavior. Something was stirring, not in any one place, but everywhere. Oceanographic sensors, too, began to act erratically. Pressure monitors on the seafloor in the Pacific recorded brief, inexplicable changes, the kind that would normally correspond to centimeters of water displacement, though no storm or tidal event could explain them. The anomalies followed a schedule. Every flare from 3I-ATLAS was mirrored by a faint echo in Earth's systems, like the resonance of a bell. The word resonance began appearing in internal reports. A few physicists argued that it wasn't purely metaphorical. Their theory was strange, but less strange than the data. They proposed that the Sun, Earth, and 3I-ATLAS had become temporarily phase-locked through electromagnetic coupling. The interstellar object's enormous charged sheath interacted with solar plasma, setting up a standing wave across the heliosphere. That wave, they said, could subtly modulate Earth's magnetosphere, pumping minute amounts of energy into the planet's magnetic field, enough, perhaps, to shake loose stress already waiting in its crust. One researcher compared it to a child on a swing. "You don't need much force," she said. "You just need the right timing." In laboratories and observatories around the world, skepticism turned to fascination, and then to quiet unease. The more they studied it, the more it seemed that 3I-ATLAS was harmonizing with the solar system itself. Its plasma tails pulsed in frequencies that matched Schumann resonances, the electromagnetic background frequencies generated by lightning strikes in Earth's atmosphere. When converted into audio, the pattern sounded eerily musical. Deep, low throbs that climbed in pitch during solar flares and softened during lulls. Theorists began to wonder if 3I-ATLAS's charge distribution could act like a giant antenna, amplifying background electromagnetic noise and feeding it back into the solar system. That feedback might not just light up auroras, it could nudge entire planetary fields. History suddenly felt closer than it had in centuries. Scholars of ancient astronomy were quick to point out that the earliest civilizations had noticed similar alignments. In Chinese records from 312 BCE, a red broom star was observed for weeks, followed by a great trembling of the earth. Babylonian tablets described a comet that wrote fire across the heavens before the lands split. Mayan codices spoke of the serpent of the sun, whose breath made the mountains move. For generations, scientists dismissed those stories as myth, coincidences born of superstition. But now, with magnetometers humming and auroras burning over equatorial cities, the lines between folklore and physics began to blur. At the European Space Agency's Solar Monitoring Center, one astrophysicist stared at a live graph of the solar wind density and muttered, almost to himself, "It's listening." He meant it metaphorically, or so he thought, because as more data came in, it looked less like the universe was passively unfolding and more like some invisible circuit had closed. The sun would flare. 3I-ATLAS would brighten, Earth's magnetic field would quiver, and deep beneath our feet, the seismographs would tremble in sympathy. The intervals were too precise to ignore. One scientist proposed calling it the ATLAS coupling, a resonance loop linking star, interstellar visitor, and planet. He published a draft paper under embargo. It was withdrawn within days. Outside the scientific community, the sky itself told the story. Nights glowed red at the horizon, birds migrated off course, compasses spun in aircraft, Power grids flickered under surges of geomagnetic induction. Around the world, people stared upward and felt that ancient, unreasoning fear return. The sense that something vast and unseen was moving both above and beneath them. And in the data centers, those who understood the numbers began to feel it too. Because when they overlaid the frequency graphs, solar plasma oscillations, geomagnetic pulses, 3I-ATLAS's light curve, seismic tremors, ocean pressure waves, all of them aligned in harmonic ratios. The universe, for one impossible moment, seemed to be in tune with itself. But harmony, in the language of physics, is not peace. It is potential. When frequencies lock, they can amplify. A violin string can sing or snap. Across the observatories and satellites, the synchronized pulses grew stronger. The planet itself seemed to hum faintly, a resonance buried in data no one could yet explain. And in the crimson coma of 3I-ATLAS, the light rippled again, pulsing faster, brighter, more deliberate, as if aware that something, somewhere, had finally begun to hear it. If the ancients were right, this crimson visitor doesn't just herald disaster, it conducts it. By late October, 3I-ATLAS had crossed the orbit of Mars. The planet hung ahead of it, like a burnt red lantern in the dark, its thin atmosphere already trembling from the surge of solar activity. Every probe and orbiter stationed there, MRO, MAVEN, even the aging ExoMars Trace gas orbiter, registered electromagnetic spikes, unlike anything recorded before. At first, the spikes appeared as background hiss, random bursts of static in the magnetometer readings. Then the pattern emerged, regular, rhythmic, almost biological. Waves of charged particles pulsed through the Martian atmosphere, rolling from pole to pole like invisible tides. The auroras that followed were unlike any ever seen on that world. Vast sheets of crimson and violet light that bled across the sky, visible even to the surface rover's cameras. The object was closing in. Theories that had once sounded absurd now took shape in closed-door meetings. Astrophysicists proposed that 3I-ATLAS was acting as a plasma conduit, a bridge between the sun and the inner planets. Its immense charged sheath interacted with the solar wind, forming a resonant circuit that linked celestial bodies through electromagnetic feedback. It was not simply moving through the solar system, it was connecting it. And yet, as the object approached, every known model failed. Predictions of its brightness, its trajectory, its coma dynamics, all collapsed under data that behaved as though the laws of physics had started to improvise. When the sun released a moderate coronal mass ejection, the comet should have dimmed as particles stripped its outer gas. Instead, 3I-ATLAS brightened, flaring with precise, pulse-like regularity. The pulses came every 11 minutes, matching the periodic oscillations of the sun's own magnetic field. It was as if the two were in conversation. Scientists refused to use that word publicly, but in the privacy of encrypted emails, the tone changed from detached analysis to dread. It's mirroring solar behavior, one astrophysicist wrote. It's not a comet anymore. It's a node governments responded in predictable silence. NASA's live data feed went dark under the pretext of signal calibration. ESA mirrored the blackout within hours. The Indian and Chinese space agencies followed suit. For the first time since the dawn of the Internet, real-time astronomical telemetry simply vanished. Officially, no one was watching. Unofficially, hundreds of independent observatories and amateurs filled the gap. On encrypted forums, they compared notes. Photometric graphs leaked in fragments. 3I-ATLAS's luminosity was modulating in what looked like coded intervals, binary-like flickers across the electromagnetic spectrum. Some claimed to have decoded the intervals into repeating harmonic ratios. Others dismissed it as pareidolia. But then came the rumor no one could confirm. At 0413 UTC, a private telescope array in Chile reportedly captured a brief image of the object's inner coma, resolving into a hexagonal structure, like a vast, rotating lattice of charged filaments. The image disappeared within hours. So did the observatory's website. By early November, Earth moved into conjunction, lining up with Mars and the Sun. The geometry of the system placed 3I-ATLAS directly along the same solar magnetic corridor that threads through the planetary orbits. Space weather centers predicted turbulence. What followed was chaos. Solar wind speeds doubled. The auroral oval expanded to the equator. Power grids flickered across North America and Europe. Satellites in medium orbit dropped offline as radiation levels surged. Magnetometers on the ground began to tremble, not from geomagnetic storms, but from oscillations in the core field itself. The Earth's magnetic north began to wander, accelerating by kilometers per day. Compasses turned unreliable, and beneath the crust, something answered. Seismic stations in Iceland, Chile, and the Pacific Ring of Fire picked up low-frequency vibrations, sub-audible pulses that repeated at intervals of 11 minutes and 2 seconds. The same period as 3I-ATLAS's brightness modulation. The connection was undeniable. Someone in a lab at Caltech called it Earth's heartbeat. The name stuck. The pulses were too faint to be felt by humans, but sensitive instruments recorded them as a global tremor, a synchronized rhythm resonating through oceans and continents alike. The wavefronts converged on no single epicenter. They emanated from everywhere. The idea that the planet could vibrate in unison with an interstellar visitor was impossible. And yet, it was happening. By now, even the skeptics had fallen silent. Computer models broke down when they tried to simulate the feedback loops between the Sun, 3I-ATLAS, and Earth's magnetic field. Energy inputs no longer balanced outputs. Equations diverged into chaos. Plasma physicists described the system as non-linear, to the point of self-awareness, a state where feedback creates behavior that mimics intent. The old word for that, whispered half-jokingly, was life. Reports of strange atmospheric phenomena followed. Red sprites, massive electrical discharges in the upper atmosphere, were seen as far south as the equator, illuminating the night with brief, blood-colored flashes. In the oceans, deep-sea hydrophones recorded infrasonic hums echoing the same 11-minute cadence. Dolphins and whales changed their migration routes. Birds abandoned long-established flight paths. Across the world, the sky carried a faint tint of copper at twilight, a spectral signature of ionized dust drifting from the comet's tail. The night of November 7th was the tipping point. At 21:42 UTC, 3I-ATLAS's light flared one last time, saturating detectors. Its spectrum split into discrete bands, infrared, visible, ultraviolet, each pulsing with the rhythm of the Earth's heartbeat. For nearly a full minute, the entire heliosphere seemed to vibrate. Spacecraft around Mars and Earth simultaneously lost orientation. Then, abruptly, the light steadied. The Sun, responding as if to a cue, erupted in a massive X-class flare, the largest in recorded history. A shockwave of plasma surged outward. But when it reached the region of 3I-ATLAS, the wavefront bent. Instead of scattering, it refracted, redirecting a fraction of its energy along the orbital path toward the inner planets. Earth's magnetosphere convulsed. Auroras ignited across the equator. Power grids collapsed. The global seismograph network erupted in alarms as tectonic plates, already strained, slipped fractionally against one another. In that instant, the heartbeat became a growl, deep, resonant, unbroken. And then, silence. When the storm subsided, the object was gone. Telescopes searching its predicted course found nothing. No residual trail, no debris, not even dust. It had vanished as suddenly as it came, as if erased. The world woke to quiet skies and uncertain instruments. The official narrative framed it as coincidence. A coronal mass ejection, magnetospheric oscillation, solar maximum behaving unpredictably. Few believed it. The data, what little escaped deletion, told a different story. The rhythmic pulses in Earth's magnetic field had not stopped. They had merely slowed, stretching from 11 minutes to 12, then to 13, as if the connection was fading, but not gone. And so the question remained, what exactly had passed through our solar system? A comet? A probe? A piece of cosmic debris tuned to frequencies beyond human understanding? Or had it been something deeper, an instrument of resonance, an agent that turned the solar system itself into a single trembling string? Perhaps comets were never messengers at all. Perhaps they were catalysts, triggers in a vast, universal composition. Maybe the universe isn't silent as we once thought. Maybe it's a symphony, and somewhere, out beyond the edge of light, something alien had just struck a new note. The ground beneath us held steady for now, but deep in the data archives, the heartbeat still whispered, patient and unhurried. The narrator's voice fades to a whisper. The ground has already answered once. The next time it speaks, it may not stop.